Okay, everyone. I've got the super secret signal from the top, so I will get started this morning. Thanks all for coming. I know it's very early. So we're going to be talking about matchmaking today. This is the advanced level talk. We're going to be moving pretty fast, so I hope you've had a lot of coffee, because you might need it. We're going to be talking about how it integrates with multiplay as well, which is where I'm going to start today's talk. So I'm Josie. I am a developer at Multiplay, and I work on our hosting platform. So what do Multiplay do? We specialize in hosting real-time multiplayer games. We've actually been doing that for over 20 years. We are older than Unity, which is pretty impressive. Most of our customers are using our hybrid scaling model. What that means is you have the best of both of bare metal and cloud. We're also multi-cloud for resiliency, which just gives us a lot of options. We, specifically for this talk, also offer a resource orchestration platform, which just means that you need to tell us when you need some compute, and we'll go and get it for you. Little plug, we're also engine agnostic, but I obviously won't talk about that too much at this conference. So the bit that we're going to be focusing on today is our allocations system, and this is the front end into that resource orchestration platform that I was talking about. This is the main integration point for matchmakers into our system. This all starts with an Allocate API request. The matchmaker here he's looking at trying to group players together and gathering data to make that decision. Multiplay are being delegated to find the best server to host a game session. In this way, your matchmaker and multiplay can have a separation of concerns. So your matchmaker just needs to focus on the players, what type of session they want, and then at the point where you're ready to schedule a piece of work and you need some compute to host that, that's when you're going to make this allocate request. Now, the nice thing is, this is already integrated in the multiplay matchmaker, which Caleb is going to be talking about in a second. But if you have got your own matchmaker already, then this is the point that you need to integrate with. So let's have a look at what an allocate request looks like. Critically, we've got 4 request parameters: profile, region, UUID, and fleet. I'm going to go into what each one of those looks like in a second. This is just an acknowledgement of your request. We're going to go and fulfill it in a second. So this is an asynchronous process. You'll actually get the server details back in a minute. So the first thing you have to provide is the fleet. This is just the group of servers that you want to allocate into. All of the scaling that we do happens within a fleet, which is why it's important. Regions is where in the world that server needs to be hosted. So your matchmaker has to have made that decision before it calls this endpoint. We have a QoS platform, which is able to help you decide where your players need to be. So your game client make a QoS request to all over the world, figure out where they have the best connection to, and that's where we'll aim to give them a server. This can follow your player density as well, so you can decide the best place to have your servers based on the latency tolerance of your game. The other parameters is the profile. This is basically a set of configuration information. So again, your matchmaker needs to have decided what type of game it wants to be hosted, and that's decided in the profile. And then the allocation UUID. This is how you track the life cycle of that allocation, so like server session. It also makes the request idempotent. So if you request it, you're not going to keep requesting it again if something went wrong in receiving the response. So all of that is just the request for something. We now need to go and fulfill it. Now, this only takes about a second normally, so it's a really quick process. And we just go into what's happening in the background here. What we're talking about here is game servers running on a machine. And specifically, they are running. We're always trying to keep those up so that when an allocation arrives, your players can connect straight to it. We also have many servers running on a machine. It's not multi-tenanted with different customers. It is just your servers here. And we've pre-installed those ready to go at this point. The next thing we need to decide is where to host those. Now, you've already given us the region, So within that region, you'll normally have some bare metal and some cloud. The allocation system is focusing on filling up the bare metal first. This is just the cheapest way to do it, because then we only use the cloud when you absolutely need to. Now, if this was in your machines that you've got, say the one on the far left-hand side is bare metal, one on the right-hand side is an expensive cloud. We'll fill up all of the servers on the machine before we move to the next one. So we're not doing like a round-robin type of thing. We're instead filling up all of the servers. This makes it really scalable. It's really clear to see which machines need scaling up or down. Ultimately, we're aiming to lower the server fragmentation across all of the machines in your environment. If you were in my talk yesterday, then you'll know a bit more about the reliability that we provide as part of this as well. The other thing to call out is that you shouldn't have noisy neighbor problems here, because we've already calculated the optimal number of servers to run on one machine. Now, the way that we allocate a server on a given machine is pick the hot machine. So this is the one that we're currently filling up. So it's the fullest machine with available servers, so server that hasn't been allocated yet that's running on it. And this is the machine we're going to choose, and then we'll find the server. Now, the other piece of information that you provided was the profile. We're going to aim to find a server that is running on the profile that you specified. That just makes the whole process really quick, because a profile change means having to restart the server, so that can take a bit longer. Sometimes you do have to do that, though. So if your game behavior changes based on startup parameters, so in this example, you want to go from like a casual to a ranked game mode, maybe you have some specific stuff you need to be reloading off the disk, then you'd need a profile switch. We just use a sig term to take out the old version and bring up the new version at the point that we're allocating it. There are other ways of doing this that don't require a server restart, so if this process becomes quite slow for you, you might want to look into doing that. The nice thing with this is how we switch versions once you've updated. If you need to update the game server, so we have like an A/B switch. Also, if you want to do A/B testing on your players to see stuff, you can use profile switches to do that too. So the server is now ready to host a game session, but you've only requested it, you haven't found out what it is yet. To find out what it is, you just call this allocations endpoint, and that will return the details of the server once it's ready. You then need to pass the server details back to the game client. So at this point, you have to guarantee your server is ready to accept client connections, because presumably they're going to be arriving pretty soon. Finally, once the session has finished, you need to call deallocate. So you have to think about, is this session actually finished? New sessions are going to arrive after deallocate has completed. So if you have any kind of post-processing you need to do on your game server, maybe it's got to update some achievement data or something like that, then you have to have done this before you call deallocate. This basically just clears down any allocation information and gets it in a state to accept new sessions. So with all of this in mind, I'll quickly touch on our scaling product, which is just making sure you always have these servers available when you're calling allocate. So we run this model using a buffer. So you can see there's a gap above the allocated servers and the total number of servers. We don't scale down into bare metal, which is what that straight line on either side is. But all of this is done in advance, so you've always got more servers than you need. And all of this is configurable to your game as well. So depending on the gradient of your scaling, you can adjust your buffer. Now, the system that we were talking about earlier with how we allocate machines feeds into the scaling, mostly because by filling up one server at a time, we'll eventually get this unused machine on the end here. This means we can scale it down without knowing any players are going to arrive on it at any point. So this keeps our costs down. This also helps us with scaling up as well if we needed to bring a whole new machine's worth of capacity online. So with all of that in mind, you need to think about how to integrate it with your matchmaker. As I say, the multiplayer matchmaker Caleb's going to talk about in a second already has its integration built in, but there's still a couple of things you need to think about to understand what it's doing under the covers. So we'll go through those here. You need to think about how is your connection information going to be passed back to your clients. As I said, the game server has to be in a ready state. So do you need some kind of time difference between there so that once the clients are ready to, you wait a little bit before you give the information to the clients before they connect? How do you solve for player density across regions? We've got quad servers all over the world, which will help feed that data, but maybe you want to customize how you choose regions for your players based on different parameters. How are the custom requirements configured, such as map and mode? As I say, we have profiles for this, but there are other ways that don't involve a server restart. And what concerns does the game server have in accepting new matches? What does it need to do before the clients directly connect? And finally, when a deallocation is processed, what do you need to do before that happens? So with all of that in mind, I'm going to hand over to Caleb, who's going to talk to you about matchmaking. Thank you.
Great. Thank you so much, Josie. So my name's Caleb. I'm tech lead on matchmaking at Unity. It's really nice when we start talking about matchmaking to kind of cover a little bit of information about how your dedicated game server host does regional scaling based on pressure, how that allocation is actually going to work, as well as how you actually configure your game server when it starts. So it's a good introduction to the concept of matchmaking. So about a year ago, we started talking about a new matchmaking system for Unity. So today, I'd like to cover where we are, how to use it, which then, of course, leads into multiplayer matchmaking beta coming in fall for multiplayer customers. So it is fall now, so that's coming pretty soon, so keep your ear out open for that news. So whether you have existing online infrastructure or you're just now getting started with those multiplayer conversations, this will be the easiest way to go from I have netcode and a game server and my game clients can connect to I have a globally available multiplayer game running on multiplayer. So when it comes to introducing some of the concepts like the why and how when you're starting to build a matchmaking system. We have covered some of this in talks before, so you can find those online. It's a good way to kind of get over some of the, we have this intuitive way that we think about matchmaking. It seems really simple. In those talks, we cover some of the challenges that you get into when you deal with actually having a successful game that will tip over matchmakers. So definitely go check out those talks. This is the advanced talks. We're going to briefly brush on some of those kind of the high level and then dive into some of the more advanced topics. So shown here, we kind of have our initial intuitive understanding of matchmaking. On the left, we have our game client. It's going to be connecting to some type of matchmaking system, in this case, like an online service. Matchmaker is going to group the players together based on some criteria, make a request to our game server host with multiplayer that Josie just talked about, and then get back that connection information and return it to the game client. Even at this level, we do see designs start to mix those arrows around. Some have client-based matchmaking, like peer-to-peer matchmaking. We also have a common design we see is that game servers wake up and register themselves to Matchmaker. And so while this does work for certain types, like kind of like trickle-in matchmaking where you already have servers and you want to start just constantly filling them, this kind of Matchmaker out allows you to respond to the actual players that are in matchmaking where they are, so handling your regional player density. And what multiplay does really well is you just create pressure in a region by saying, give me more servers. My players are currently in US East, for example, and it will actually do the heavy lifting there. So you don't have to concern yourself with that. You just need to make the decision of where the players are close to. So advanced talk, we're going to pull the curtains back a little bit and talk about the what's going on under the hood, and also talk a little bit about what's not going on here. Get to that in a second. It's the same boxes before. On the left, we have our game client. In the middle, we have our online multiplayer matchmaking infrastructure. And on the right, we have our game server hosting. And then this extra component here, which is we're also shipping as part of the beta, is a command line interface that's going to allow you to easily interact with and manage some deployments and some of that online infrastructure that you're going to need to manage when you integrate with multiplayer matchmaking. So again, starting from the left, we're kind of do like a whole flow here to kind of level set. So the game client's going to need to authenticate itself to some services. So we're going to talk to an identity system. We are working on a sort of bring your own identity. So if you're integrating with a platform or you have your own identity, we'll be able to auth-z you against that identity. The game client will then connect to the QoS, quality of service systems that are hosted on all the multiplayer data centers around the world. This allows you to measure latency, maybe transfer a few bytes, measure packet loss to those systems, collect that information, pass it through to a lobby system. You can pass directly through to the matchmaking front door. We'll get to some of the challenges involved there, but if you have an online game system that relies on getting that player data securely, so like if a player's like, yeah, I'm matchmaking and I am a grandmaster, but they're not, you don't want to be susceptible to those types of tomfoolery that a game client might do if someone's intercepting those packets. So you normally have some type of service-side database where you're actually going to store that player data. So you want to make sure you hydrate from that data before you pass into the matchmaking front door. So at this point, you're technically, like the player or players are matchmaking, kind of the colloquial way of thinking about that. It's worth stopping briefly to say that this matchmaking API is actually a totally RESTful service. So in the same way that multiplay is an engine-agnostic way to host games, if you are working with a language or an engine that can make web requests, you can still integrate with this matchmaking system and get that good access to multiplayer game server hosting. So this leads us to this middle gray part. The gray part is an open source project we managed with Google. But the point of that, which I'll talk about a little bit later on, is to enable the inner green part, which is then to enable the inner blue part, which we call custom match functions. And this is really the real power of this type of matchmaking system. This allows you to write your own code and use this as like a game design tool for actually putting players together the way you want them to come together, instead of using some type of rule-based thing where you have to like understand the rules and generate the rules. You can just write this yourself. And so here we come into the back end here, kind of maybe showing some of the back end here, but the directors that you can't get away from the scheduling side of writing online services that do work. So you can think of, we have some stuff that's going to loop. That's what the director does, and you can think of it as like the gas pedal for matchmaking. We have some configuration into that allows you to kind of tune how quickly you're able to run some of this, run all of your match functions. And then the really nice part about this is it automatically integrates with multiplay. So there's a couple of concerns you have to be aware of when you're writing a match function, but outside of that, the heavy lifting of doing the allocations, speaking to multiplay, tracking those allocations, and then eventually returning that information that multiplay gives you back through to the waiting game client is all handled inside of this. So the blue parts are not actually included in the multiplay Matchmaker beta. So what that, well, let me preface that. The blue part is something you have to provide for the custom match functions. But it's interesting here on the left, because it almost doesn't feel complete in a way. But when we went about designing this matchmaker, we wanted it to be a purpose-built, drop-in, very powerful, massive scale matchmaker to answer this question of when your game inevitably gets successful, you don't want this thing to fall over. And so if you have online infrastructure for your game, party, lobby, session, maybe you integrate with platform services. The idea is if you just start routing tickets into this system, there's not a lot of additional integration you have to do. This gives you more or less immediate access to multiplay hosting. Otherwise, you would have to build this yourself from scratch. However, we are working towards a batteries included matchmaking system where more or less these blue parts will go green. So we're going to work on like a la carte versions of these that automatically integrate with the matchmaker. So then you can just get matchmaking and not worry about the online part. So with the summary out of the way, we can kind of get into the nitty-gritty of what it does and how to do things with it. I hope to, over the next couple of minutes, leave you with two things. One, an understanding of what this matchmaker does, how its APIs work. And two, about halfway through this, your game design side will switch on and you'll start to think, well, I actually have requirements and things I want to do, and I can sort of understand how it would fit in, but I have some questions. So we get a lot of questions about how to do very common scenarios, and it's worth taking a minute at the end to kind of machine gun through some of those. So before we dive into that, if you are going to go it alone in matchmaking, and at the end of this, you're like, that's great, but we run an online, game service, or maybe my business is matchmaking, I highly recommend checking out OpenMatch. A year ago, we co-founded this open source project with Google. It's up on GitHub. It's free to go in and start looking at. The idea here was we wanted to implement a generalized way to solve for the infrastructure side of matchmaking, especially doing highly concurrent, scalable, custom match logic, which are the two big parts that are difficult to handle when you're writing your own matchmaker. So there's the plug. If you're interested in learning more, feel free to go check that out. We have pretty good, pretty healthy community involvement there. Some games have started showing interest in that. The main benefit of using like the multiplayer matchmaker, it's going to be the usual suspects. Hosting is handled for you. Service expertise, the connected games team at Unity, is really a great effort from folks who have experience in AAA online services development from like all kinds of, I'm not going to say the names, you guys would know them, but, and then of course you get your SLA, your Unity ecosystem integration, and then the automatic multiplayer integration. So of course, leaving that up to you to evaluate as you have time. Diving into the front door, what's a ticket? So the four parts that I listed previously were tickets, match functions, configuration, and evaluation. So first, chewing off tickets. You can think of this as your request to do matchmaking. It's got three parts, attributes, properties, and an assignment. We'll talk about assignment first. This is going to be the final thing that happens to the ticket when matchmaking is resolved, the allocation, or possibly an error that your match function is going to provide. It's going to include connection information, IP import of the server. It's going to include any custom properties you want that ticket to be aware of, like, for example, what map to load while you're starting to connect to the game server, client side, or even like what team you're on or what the other players are that are going to be in your game, so that you could show some UI or do some logic on the client. You also have an opportunity here to bubble up errors. Maybe you have a player who's been waiting a long time because they submitted some weird data. You could have a function that purposely times out that client and allows you to maybe do some type of patching to try and fix that. In the meantime, you want that client to be aware of the problem. Next, we'll talk about attributes. If you've worked with databases, this is going to be indexable fields that you're going to put on your ticket. Tickets can be surprisingly sparse. You do need to submit an attribute, but besides that, you could submit a relatively empty ticket if your goal is just to do like bucket fill style matchmaking. Maybe you don't care about the custom part. But the sky's the limit here. So, the example I like to use is when you activate your match logic, you're going to have an opportunity to query for these. So you would say, like, give me all tickets where skill is between 1,300 and 1,600, and I'm looking for tickets where the role is set to tank. So maybe in my match logic, I'm doing like team composition, hydration from tickets where they've specified caster, healer, tank. So that's one way you can drive this. It's worth noting at this point that tickets are not one-to-one to a player. Tickets can be kind of anything, and a very common thing we see that folks need is, well, I have a ticket that represents more than one player. To do that, you might put a player count into your attributes. Maybe you want to find tickets that are exactly 2 people for some team social playlist. And what you might do is you would put the rest of that player data that represents the party into the properties section of the ticket. Properties are the rest of the concerns you might have in your matchmaking logic that you might not be able to capture at the database. So this is going to be like one of my favorite kind of ways that a multiplayer ecosystem could work is by progressing through the campaign, you unlock multiplayer maps. So at this point in that ticket, you might say what maps they've unlocked. This allows you to find other tickets that just have those unlocked, and so you can create that kind of social connection as players are moving through the system. They're moving through it together until they eventually unlock all the maps. Let's see, do I have another example of that? Oh, another one is you could put like the inventory of the current team in there. So you're able to look at their current loadouts and know, well, their skill is pretty good, but they have these like really crazy rare weapons. So maybe I want to find an even slightly better team for them to play against than a skill system would normally give you. So that's properties. Oh, we have an example, right? So in attributes, we have some indexable components, mode, team skill, player counts. I've really proliferated some information into properties, so I have some party info. I could use that in my match function to say what other players are, like their localized names that you could throw into the ticket assignment so everyone can see everyone else that's loading into the game. We also included here an example of some quas information. So this is going to be, my ticket has some, these are the 2 data centers that I have a good connection to. So in a match logic, I can read this and try to find other players that have the same high quality connection to these places. Which brings us to really the core of this matchmaking infrastructure. I've already kind of touched on it like 19 times already, but we can actually talk about it now. Who here has heard of like AWS Lambda or Google Cloud Run, kind of serverless? Yeah, there's a bunch of different names for these products. You can think of this as being like a purpose-built version of that integrates with Matchmaker. So with this, you're going to get the ability to write whatever code you want. We will then upload it, we'll host it, serve it, activate it, and horizontally scale it up to whatever your needs are. What you get as part of the beta is some tooling for doing local simulation and unit testing, load testing, so you can understand the actual performance of that when you put it under real load. That includes some simulator for like ticket generation. We have an interesting direction we really want to head here around making sure that you can actually test your functions instead of just uploading them and praying. We have an API, of course, for managing those functions that you can integrate that with whatever DevOps or CI/CD workflows you're working through. Right now, we support getting logs from those functions as well, so you can actually see them getting activated, debug them. We have some direction we want to head here around like remote debug and crash dumps that you can see really detailed information from your live match functions that are running in production. And then as part of the beta, we're also shipping a bunch of kind of recipes. We do want to move towards canonical functions that kind of answer a great margin of concerns. Initially, though, we're going to do snippets, and you'll be able to kind of use those snippets and construct exactly what you want in your match functions out of the gate. So basic recipe for match functions. You get activated. You will construct and run a query. This is going to be that thing I mentioned earlier where you're looking for certain players from your database that meet your needs. The second one you can think of as actually doing like the magic. So you're gonna group the tickets based on whatever your criteria is, and you're gonna make a proposal. You'll be returning the proposals at the end of the match function execution. Not only are proposals like the groups of the ticket IDs, but we have the opportunity here to make some additional decisions. So, for example, if you're in your match function, you want to roll a die and pick a random map you're going to play on, you have the option to pass some information here to the dedicated game server, which will be available when you get allocated. You get activated, you can go read this information. So this is another way of doing runtime-based config that you're deciding based on the players you're actually going to be putting in the match. You can also do, in that assignment properties I mentioned earlier on the tickets, you can specify like what team or role they're going to have. We'll come back to overrides. Just know that there's this thing we're going to touch on later where you can activate some special backend logic that might skip parts of the pipeline. And then you can also, at the end, you'll need to score and return the proposals. And he moves on, skipping right by score. We'll cover that in a little bit. I want to take a step back. I think visualizing just kind of the breadth of data, and this is like scratching the surface on what you could have available to you in your match function. Many of these fields are indexable, so you can do a lot of like highly efficient query forward ways of getting this data for the tickets. But just covering a few, we have skill, reputation. Maybe you want players with bad rep to be isolated to a little island, so they're not playing with your main population. How long tickets have been waiting is a really critical one. My favorite is the current win streak. if I have won 8 games in a row, only matchmake me with other players that won 8 games in a row. So every match gets just that much more intense. So there's a lot of matchmakers out there that do configuration-based, rule-based matchmaking. One of the things that just kind of capturing the scope of what you're able to cover here. I'm not going to go through all these, but things like combining 2 parameters to form a new parameter based on a potential match is something that you can do that's very difficult to do in other systems. I think the level setting one I like to work with is the conditional attribute weighting. Let's say I have players who have a particular skill, but my confidence of the skill is low. I have the option to switch to other parameters to try and figure out maybe in that moment a slightly better way of understanding if the players are good. Maybe I have it on good authority that that player logged in the game for an hour, went and watched 10,000 hours of master play, and they're coming back. I don't know how I would get that data necessarily, but maybe they play another game that you've produced, and you're sharing some of that player data across games, so you know that they're already familiar with the mechanics, so you can really control some of their progression as they ramp up into the new game as a part of this logic. So we've covered tickets, we've talked about match functions. So besides just hosting them, it's important to understand how we actually activate those functions. And so this is where we're not completely configuration-less matchmaking system. The goal here, though, is to allow for you to control how your functions are going to get called. So there's 2 segments to a configuration. The first one is that multiplay configuration. So this is going to be the profile Josie talked about, as well as credentials for manipulating the multiplay fleet and allocate API on your behalf. The kind of important part to take away from this section is Josie mentioned profile switching. So if you want to put out a new build of your game server, and you want to do some mode configuration on that side, that might involve some pretty heavy lifting to restart your servers, which could cause some issues, especially when it comes to if you're having to do that with pretty high iteration or you're trying to fix a bug. So the solution there is that you just have 2 profiles and you're switching between the 2. Here's how you could do that. You just change the profile ID to the one that you've already warmed up with the new image, and your match function will now automatically start allocating that game server image instead. So you can imagine just having one configuration and updating it, or even having 2 configurations side by side, targeting different ones and actually changing the mix if you really want to have granular control over bringing that online. Getting to the rest of kind of what I think of as the generator configuration. We have a name. This is useful for me to know what I'm using it for, in this case, capture the flag competitive. We have the function we uploaded that we're actually targeting. So that's the function that we've already uploaded and we're hosting it. And then there's these 2 sections, which I'll do out of order on the right, in order on the left. Config. These are going to be parameters, think of them as args to your function. You can pass in whatever you want. You have the ability to understand those on the match function implementation side. So in this case, my team skill function understands these team parameters. So in this case, my CTF will be 2 teams of 3 to 4 on each team. I could reuse the same function to run other playlists that might have 2v2, v2, v2 by just changing those parameters. The last section there is pools. So this is going to be an initial query that you're going to get activated with on the match function side. You have the ability to change it. So it doesn't seem initially super useful because you could almost just write this into your match function if you wanted to. It almost kind of looks like config. In this case, I'm saying take the skill parameter and give me everyone between 0 and 3,000. In this case, maybe my skill is only between 0 and 3,000. So this is going to actually hydrate every single ticket that exists, which leads to this question. What happens when the performance isn't up to snuff and I'm getting too many tickets and I can't process them all? Of course, things are going to slow down. That's going to adversely affect all of your matchmaking times. And so the answer to this, remember we have this highly scalable middle layer for custom match functions, is to just do more of it. So we've made a second config here, and we've sort of segmented skill. On the left, we have 0 to 1,600. On the right, that one is concerned with 1,400 to 3,000, so the higher end of that tail. You'll note that we don't make you perfectly segment this, which makes a bunch of interesting issues down the road, but we have answers for those as well. So In this particular case, these have an overlapping segment of skill where the tickets are going to be returned to both of these match function activations. What's interesting here is you can actually use this to great effect. You can have lots of different functions that have lots of different custom matchmaking concerns, and they can consider the same pool of tickets. Of course, that means that lots of proposals will have duplicate tickets across them, which we need to figure out how to solve. Coming back to that, though, some of you are already, I can see it, already starting to think, but Caleb, you say dubiously. What happens if I have even more tickets and the performance falls over? Do I need to make 10 of these things? So the answer is just to automate the do more part. So here we have introduced to our pool, which previously was this like static query, is now this kind of like smart auto filter generation. And so this allows us to do match function scaling when we know that our function has some performance considerations. In this case, it's the same skill. I set some boundaries. And then I have this segmentation language here. So in this case, I'm saying a little bit about my data. Skill is a normal curve. And then I'm going to try to generate 10 buckets of equal size based on the population. So my tails will have the same number of tickets, ideally, as the most populated middle part of my skill curve. This would have been a great slide to have an actual like normal curve to explain that, but I'll draw the line in the air. So we also have this golden gun auto. We're still working on auto, but the idea is here we're going to statistically analyze what the data actually looks like and break that down. And then we have two behavior types here. We have bucket count, 10 buckets, versus bucket size, where the idea is to try and guarantee a certain number of tickets from your data that would be delivered to each match function. So that one, of course, might result in way more functions getting ran as your population scales up. This is great if you want a really deterministic function runtime. Just kind of a visual of what that looks like, right? Configs go in, it generates lots of runs. They create lots of collisions, which goes into this box that has to figure out how to decollide those, and out the other side comes good matches. Yeah, let's talk about that box. This is the last part, evaluation. Like I said, I've got two proposals with my tickets. 1, 2, 4A is in both of those. So how do I know which one to pick? And so this is where we introduce a score to the proposal. And so this is an interesting behavior model because it allows you to algorithmically assess quantitative quality on these proposals that you're able to normalize across your functions. And so in this case, I've added my skill and my time that these tickets have been waiting to each one, just kind of as a visual indicator. And at the bottom, I have used this algorithm that uses the time waiting on the tickets and the difference between the skills as a way of creating a relationship so I'm able to determine which one I want to take. In this case, I'm using the root mean squared deviation. So as my error of time waiting goes past 0, it gets increasingly more important. However, if the skills are really close together, that's going to create a really low error. 1 divided by hopefully not 0, I have to fix that. It's going to result in a really important weight. I've now made those equal weights. And so I've made a relationship where if a ticket's been waiting a long time, it might prioritize that proposal if it appears in it. But I might still have this overriding logic that says, but if it's going to be a really good match, let it happen. And so in this case, the right proposal is actually better because that ticket up there has been waiting for a little bit longer. Great, time looks good. So we've covered a lot of what it is, what it does, but we still have questions about how to do some of these things, like what about playlists and player data. Briefly touched on regions, we'll touch on it again, parties, backfill, peer-to-peer, and even just development scenarios where you want to get onboarded with this, but you don't necessarily want to upload game server images every time you want to iterate your game server locally. So this part's going to be pretty quick. We're just going to move through this. Quick reminder, this is where we started at the beginning. I'm going to modify it just to get rid of some of the infrastructure parts. So some of the specific things became game services, player data services, and then we've taken all the middle parts away and replaced that with just function activation. So playlists. You basically need the ability to know what playlists are currently active. So we have a product called Remote Config that lets you tune that live so that the game clients are aware of some piece of configurable information. You could abstract that with like a mode, pass that as an attribute on the ticket, and then in your functions, you might have a pool for modes specifically. So mode 2 could be CTF. If you know you have like 10 modes, for example, you could also use segmentation there as well to generate the 10 different mode function runs if they're pretty similar. Securing player data. Covered this a little bit earlier, but because we don't trust the client, there needs to be this piece of online infrastructure that's going to store and retrieve that data. So this is where something like a lobby service comes in handy. There's a couple lobby services out there that come with platforms. Of course, we're also interested in helping fulfill this need. Region-based. Both Jesse and I talked about this, but let's come back around for it. We have QoS systems on Multiplay. You'll measure your quality to those regions. There's also a discovery endpoint to know what the regions are at runtime. You pass some information into lobby. Lobby is going to want to do some kind of combination. Maybe there's some it can throw out immediately. You might have some additional concerns where you know that a player is just always has a bad connection to a region, so you could get rid of it. And then in your actual function, after you query the tickets, you're going to want to categorize them by good regions, and then do your matchmaking inside of those regions, maybe doing some parallel work, take advantage of those cores. The last thing you do is there's a multiplayer region that's actually on the proposal, so that's some of that overridable piece of data that's available to you during match function. Set that, and then the rest of the heavy lifting is handled. The backend will call into multiply. It'll create pressure in that region, request an allocation, server gets spun up, and then it's handed right back through. And all you have to do is specify what that region is that you want to use. Parties, specify player counts. You're probably going to want some friends, invites, or session system. If you have existing online infrastructure, you probably have something like this already. And you're probably going to want to put some of that player data into your properties. An interesting use case I've seen here with properties is as parties move through matchmaking, sometimes you get in the same cycle with other players as you leave a game and go back in. So you might say in this properties section, I've seen these parties recently when I was playing online. Let's try to avoid those ones. Or maybe you want to just constantly make grudge matches between players, so you constantly try to find them together in the pool. All right, 2 minutes. There's 2 ways to do backfill, and these are kind of just the last 3 here. We do have a backfill system service that integrates. So option 1 is function. So you can actually write a function that the game server, once players get activated into the game server, we're missing a player, missing 2 players. You can kind of act like a configuration here where you're going to ask backfill to run a specific function you've written that knows how to read for existing players in the property section, as well as execute any additional parameters your game server really wants to have fulfilled. So the player I was expecting was going to be the leader of this team. They're going to have lead with skill, lead with maybe kills if you're doing like a Slayer type thing. So maybe I want to run this function and also filter for skill that's kind of especially high. Or maybe it's party-based, so I need another ticket of 2. So you can do a lot of customization here to activate a function who's specifically going to fulfill that backfill request. What's nice there is we expose this field, another override field in properties called connection override. So that game server is going to specify some already existing information. And once you set this override and resolve the proposal, assuming it makes it through the evaluator and becomes a match, pretty good reason to up the score for backfill-based proposals, the tickets will automatically get assigned this information. Which takes us to option 2, which is to do it through the front door. So tickets are really flexible. So maybe you submit a ticket that has some host information on it. And maybe you add a configuration that adds a pool for servers for existing hosts. When you activate your match function, get all those hosts, query all your typical tickets. For every host that's missing players, fill in from the pool, and then just generate your normal proposals as usual. Those will allocate new machines, but you've filled the existing machines through the same type of match logic you're already using to make the server. So that's really nice to consolidate that information. Same thing as before, it uses the connection override since you can submit that information with the ticket. So this one's kind of interesting because it actually looks like another topology where the game server is just going back through the front door anyways. So this is more or less the same thing as doing local development or peer-to-peer. If you already have a game server, like I'm hosting on my box and we're going to do a playtest together, Josie. We just submit a ticket with that information. and use the exact same match function as we're using for backfill to just go ahead and pull tickets out of that queue and throw them on the same box as I'm on. So references after this slide. So in closing, I'm actually out of time, but quick summary, multiplayer matchmaking beta this fall, which is very soon, integrates automatically with multiplay and deeply customizable matchmaking logic. We have some other talks, definitely check this out. Later today is the Mad Finger is actually using this matchmaker in multiplay to full effect for their mobile FPS title, War Games. And we actually don't have time for questions, but Josie and I will be hanging out in the hallway after this if you guys want to ask us questions or maybe you have a flow you want to bounce off of us. Happy to talk about it. Thank you so much.